First of all, yes, the meeting is being recorded. I wanted everyone to know that, and as such, please mute your mic while the speakers are on. I'll go ahead and introduce the speakers, and then we'll have any questions afterwards. Thanks everyone for joining us on the CSG Virtual Drone Workshop live chat number 9. We've had 8 of these already. We've been busy in the last year since COVID prevented us from having the in-person workshop, and but we hope that these and these live workshops and the website have been useful to everyone, and we will continue with these, and we will continue evolving the website. Our speakers today, the presentation is on collaborative advances on the use of drones for conservation in Argentina, and our presenters are Antonela Panebianco, who is a postdoctoral fellow at the Wildlife Ecophysiology Research Group in Patagonia, and she studies development of methodologies, among other things, development of methodologies for study and management of wildlife using drones, and also estimating the impact of the drones on wildlife. Our other presenter, Wade Sedgwick, is with the Island Foundation, and he's a drone pilot and wildlife conservationist who's worked with drones very extensively, both fixed wing and rotorcraft, and worked all around the world, basically, collaborating with WCS affiliates. Most recently, if you remember, we had a presentation with the park ranger from Gabon a few months back. Well, Wade actually was over in Gabon a few months ago working with that park ranger. So he's done quite a lot of work, and he's going to be talking about some of what he's learned from his experiences today, working in Argentina as well. And another co-author on the presentation is Natalia Schroeder, who's a biologist with the Argentinian Institute for Arid Zone Research. And she is researching the use of drones as novel tools for monitoring wildlife that is of ecological, recreational, or productive interest. And so I'd like to welcome and thank our speakers in advance and turn it over to Antonella. Thank you. You can share your screen.
Thank you, Raymond, for introducing us. Okay. So, can you see this? Okay.
Yes. Yes, you can go to slide mode. Great.
Okay, great. So thank you all for being here. Today we wanted to share with you some of the work that we have been doing for the past few years. So we organized this talk into 3 parts. In the first section, I'm going to briefly summarize the work that we've been doing with Natalia and colleagues about the experimental approach to assess the use of drones and its impact on wildlife. Then we're going to move to describe all the collaborative work that we've been doing with WCS. And finally, Wade will take it from there to share his experiences using drones for wildlife surveys in South America. So it's no news for us here today that drones are great tools for research and conservation. Their use is growing rapidly, and they offer a bunch of advantages related to cost, the safety for operators, the access to remote areas, and the very high spatial and temporal resolution. But drones are still in a trial phase. The research on the potential impacts of drones is recently being seriously considered, and there is a call for more experimental approaches. So, using an experimental approach and the guanaco as a study model, the guanaco is the largest native herbivore in South America. We aimed to assess the variation in counts of adult and offspring in images taken at different heights, evaluate how social traits together with flight plan characteristics influence the behavioral reaction of white guanacos to the drone's approach, and finally, estimate the reaction thresholds and flight heights that minimize disturbance in different social units. So the results of the first objective have been published in late 2019, and the results of the other two objectives were published earlier this year, just in case you are interested in more deeper understanding to what I'm going to talk about today. So we work in two areas, in North Patagonia. The first one is a protected area called La Pajunia, where there is a partially migratory population of guanacos. And the second place is Los Peucos Farm, where there is a captive population of guanacos. For these three objectives, we work with a DJI Phantom 4 Advance, which has a 20 megapixel camera and a 30 minutes autonomous flight. So for the counting objective, the first one, we combined three types of flights. We did vertical flights, where we positioned the drone above a group of guanacos and lowered it from 200 to 50 meters above ground level. Then we did horizontal flights, where we approached a group of drones at the same height and combining two different heights and speeds, 60 and 180 meters, with slow speed and a fast speed. And finally, we did a scanning flights, where we use a Pix4D software to program the drone and fly it over a square area following parallel line transects. We repeated this at 3 different heights with a minimum image overlap, and we covered areas between 20 and 40 hectares. For this project, we collaborated with Pablo Carmanchay and Romina González Muso, which we wanted to mention and thank. So this is how basically guanacos look like at different heights. While at 200 meters, which is this picture at the top left, we should have to zoom the photo to identify the individuals. At 50 meters, that this picture at the bottom right, we can easily recognize the guanacos and also distinguish the adults from the offspring, which is identified here with this white circle. So what we did with all these pictures at different heights, totaling 125 pictures, then we had 4 different and independent observers that counted all the pictures and counted the total number of individuals that they saw and also the total number of offspring that they saw in each of these pictures. So with all that information, we calculated the coefficients of variation of the pictures at different heights for the total counts. That is what we can see in the plot on the left, and for the offspring counts. That is what we can see on the plot on the right. So for the total counts, we found no difference at different heights, although we can see there is a greater variation at higher heights and some extreme values. For the offspring counts, we did find a difference and a larger variation at 200 meters compared to 60 meters. And in general, the values were more variable and higher than when we considered all the counts. We think that this higher variability means that the observer made more counting errors, either false positives or false negatives, and possibly contrasting effects of the vegetation, the small size of the offspring, or the time of day. All of them contributed to this misidentification. This variability could be improved by further training of the observers and also using some digital tools that we are currently working on. The other main interest for us is measuring the impacts of using drones. And for that, we use 2 different approaches. The first one is estimating the probability of reaction, which is the most widely used approach for the few experimental studies conducted with other species. But the thing is that 2 different species or even 2 different groups in the same population can have equal probability of reaction, but differ at the distance to which they react. So in this sense, the flight distances are much more informative because they allow us to measure some kind of tolerance, evaluate if there is habituation, and also estimate reaction thresholds. So to evaluate these 2 aspects of reaction in guanacos, we use the horizontal flights that we described before, using the 2 heights and the 2 speeds. And we analyzed the probability of reaction along with 2 different measures of reaction distance. The horizontal reaction distance, which is this one, and is the distance between the guanaco and the drone's projection to the ground, and also the diagonal distance, which is the straight line distance between the guanaco and the drone. Drones approach, like any other human disturbances, can evoke responses that are analogous to anti-predator behavior. And sociability has been proposed as a mechanism to improve these responses. In this sense, guanacos are a great model to study how sociability and group composition can modulate the responses to drone disturbance. That is because guanacos have a very complex social organization, and we can find them in different social units. We can find family groups, which are composed by a male, a group of females, and their offspring. We can also find bachelors that are male, non-territorials, mostly juvenile individuals with very variable group size. Then we have solitary males that are territorial individuals and defend little areas but are not associated with other males or females. Also, we can find mixed groups, especially in the migratory populations, where you can find females and males of different ages and with very variable group size that can reach to hundreds of individuals. And finally, female groups that are females with or without their offspring, but without any male present. So what we did to assess and consider the sociability is that during the horizontal flights, we approach different groups of drones, of guanacos, sorry, of these different social units, and we registered the group size, the social unit, and also the presence of offspring. So moving into what we found first for the probability of behavioral reaction. In these plots here, we have on the y-axis the probability of reaction, and on the x-axis the group size with different colors, the presence of offspring, and also the height of the drone flight. And we found that the probability of reaction increased with group size, but we found no differences in groups with or without offspring. Also, we saw that the probability of reaction increased at low heights, which is a very common result reported in other studies and in other species like birds or other terrestrial mammals or even marine mammals. For the horizontal flight distance, we found that there is also an increase in the reaction distance with group size, but irrespective of offspring presence. These results, along with the ones that I previously mentioned, suggest that sociability allows guanacos to improve their capacity to, to react to drones, probably by increased detection in larger groups and cooperative vigilance. And regarding the other characteristic of the flight plan, the speed, we found that there was a greater reaction distance at low speed. We think that this could be related to the relationship between drone speed and individual reaction distance. Probably because the individual reaction per unit of time is not constant with different distances among between the guanaco and the drone. It's not constant, but it's different in changes. Well, when we look at the diagonal distance, we found that family groups, female groups, and mixed groups had higher diagonal reaction distance than solitary males. And with this, we could define a reaction threshold, which is the minimal diagonal distance that we can approach guanacos without causing a behavioral reaction. And this reaction distance could also be used to estimate minimum flight heights. Because when as it is a straight line, the minimum distance, we could think that that is the minimum height that we could position ourselves above the guanacos without disturbing them or causing the minimum disturbance. Well, so to conclude with this section, we want to highlight the importance of correctly using the drones to reduce the wildlife disturbance, because it could lead also to detection bias. In our experience, and based on our studies, flying at 200 meters above ground level using a multi-rotor drone could minimize the behavioral reaction, but there is still a lot of things that we can improve. At this height, at 200 meters, we saw that approximately 40% of the groups, mostly from mixed groups, that are those very big groups with almost, that can reach hundreds of individuals. We could miss them flying at 200 meters. So probably we could be underestimating our counts. So we can still have things that we have to improve. For example, we are thinking about using low noise propellers, evaluating the possibility of using quieter drones, and also when possible, trying to fly the drone in the moments during the life cycle where these very big groups are less represented. And also we want to evaluate habituation after drone exposure and see if these behavioral responses diminish. Well, now moving into the second part of the talk, the collaborative work with WCS, we would like to mention, of course, Wade joining me here, and also Andres Novaro, Martin Funes, Lara Heidel, Alejandro Gonzalez, and Brivon Crawford, who are actively participating in this work. And we have two main goals in this collaborative work: a vegetation map and comparing ground-based and aerial counts, and I'm going to go into detail in the two of them. So for the map here, the goal is to build the vegetation and productivity maps at La Pajunia Reserve, which is one of the study areas, the protected area where the partially migratory population of guanacos live. So far, we conducted surveys during autumn of 2019, and we used an EV drone, which Wade probably will describe more later. We surveyed the different vegetation communities, and we took pictures in the ground and also using the drone. And the idea is to, we use a multispectral camera, and the idea is to use that to estimate NDVI values to build the productivity maps with very high quality of the data. For the ground-based and aerial counts, we are working right now in two protected areas. One is La Pajunia, the one that I just mentioned, and the other one is Aucamahuida protected area that is in Neuquén province, also in Patagonia. And here we use the EV drone and also the DJI Phantom 4 Pro. And we surveyed the different populations and took data simultaneously from the ground and from the drone, with the goal of calibrating and validating both survey methodologies. So far, with this second goal, we made progress in the manual counting. We developed a counting protocol using the DotDotGoose software, which is a very useful open source software that allows us to use grids to count different classes of guanacos. Here we can see with different colors as an example, the odals and the calves. This could very well serve also if you wanted to count different species in the same picture or stuff like that. And the other advantage that it has is that you can export the data in different formats depending on what you want to use. And for example, having a summary of each picture, or having each individual counting as a different line, or also having a little extracts of the picture that could be further used to train algorithm for machine learning. So that is what we've done so far. What is next? We are very excited to what we have to do next. First, we wanted to mention that we want to expand our understanding of the reaction of guanacos to drones, and we wanted to take it a little bit further by trying to understand the physiological and behavioral responses of guanacos to drones. For that, we are using biologgers to measure heart rate, temperature, and they also have an accelerometer to estimate activity. We are going to do an habituation experiment. This actually has just started. We tagged the first guanaco last week, and we are hoping to start flying the drone next weekend. After doing an habituation protocol, then we also want to explore the hearing sensitivity, as we believe that the noise of the drone is one of the main aspects making the guanacos react. For this activity, we are also counting with the collaboration of Megan Owen from the San Diego Zoo and John Whiteman from the Old Dominion University. And of course, we're going to continue with our collaboration with WCAs regarding the ground-based and aerial counts. We want to finish the manual counting and compare and calibrate the two methodologies. And also we want to explore the semi-automated counts and develop some kind of machine learning to improve our countings. And for that, we are counting with the collaboration also with Duke University. And as for the vegetation maps, we want to finish the analysis and build the first set of vegetation and productivity maps. And we are hoping to have a next vegetation survey during the Austral summer of 2022 in order to get some seasonal maps. So I will leave it for Wade to continue from here. He will tell us about all his projects in South America. So Wade, it's all yours.
Great. Thank you, Antonella, for thoroughly explaining the work that you do with guanacos and what future implications this might have for guanaco and wildlife conservation. So my name is Wade Sedgwick, and I worked throughout Argentina and a few other countries in South America from 2018 to 2020 before the pandemic brought me back to the States. I worked with the Wildlife Conservation Society as a project consultant to implement a pilot drone project for different wildlife surveys in different regions. So this is the general workflow that we use. The four main steps are project planning, flight execution, post-processing, and data analysis. In the time that I have, I will quickly walk through some of the projects I worked on. Antonella covered the work that we did with guanacos in Bajunia and Alcamahuida, but I also explored the viability of using a drone with a thermal sensor to detect invasive beaver lodges in Tierra del Fuego, and complemented manual sea lion counts with drone surveys for the 2020 sea lion census. I will also give you an in-depth explanation about the project I worked on at the Islas Malvinas, or Falkland Islands, over the course of 2 years, where I conducted the first island-wide drone surveys of the largest black-browed albatross colony and second largest southern rockhopper penguin colony in the world. I began my work in South America on 2 islands in the Islas Malvinas, Steeple Jason and Grand Jason, which are both owned by WCS. But first, I'll discuss the other projects I worked on throughout Argentina. So after working on survey plans for guanaco, as Antonella was discussing, the new fixed wing drone, the EBX, was ready. Here is the flight planning software for the drone. You can see that based on the resolution required for the mission, the drone contours the elevation data and can be downloaded before going into the field. This drone had a few additional features that the Phantom 4 did not. It was semi-autonomous, only receiving inputs such as start mission, hover, land, and dive. It had a maximum flight time of 90 minutes because it's a fixed wing, and had intricate safety procedures that would bring the drone home if it detected a software malfunction or a pickup in the wind. These are the 2 drones that were used, the Phantom 4 Pro with the camera connected by the gimbal, and the EBX, which came with 2 rigs, a 0.5 megapixel thermal sensor with a 20 megapixel RGB camera, and the other rig was 4 1.2 megapixel multispectral bands, which are green, red, red edge, and near infrared, and that came with a 16 megapixel RGB camera. In late July and early August, which was peak winter, I flew down to Ushuaia to work with researchers at CONICET, surveying guanaco, but also identifying invasive beaver lodges that were still inhabited. The American beaver has had a huge negative impact on the environment, causing millions of dollars worth of environmental damage. In a 2019 study, it was found that there are over 70,000 active beaver dams on the Argentine side of Tierra del Fuego. So these invasives create an environment that's suitable for other invasives by creating ponds that would dry out and form into meadows that aren't natural in Tierra del Fuego. This eradication will be a $20 to $30 million collaborative effort between the Argentina and Chile governments, and will be funded at least partially by the Global Environmental Fund. And if you're interested in learning more about this, there's a great National Geographic article that was published a few years ago about the impact that the beavers have on this environment. We were limited by our flying because of frequent snowfall, but we were able to fly the drone for a few days and prove with a thermal rig on the EB that it is possible to detect the thermal signature of a beaver chimney. So here is an RGB image of two beaver lodges, and they're marked with red dots, one in the upper left corner and then the other one in the bottom right. This is a thermal image of the same location, and you can see that the chimney in the top left is emitting heat, and I'll zoom into that one in a second. You can see the bottom right one doesn't really. So this is the zoomed in image of the beaver lodge that is emitting heat, and you can definitely see that it is warmer compared to its surroundings. During the months of January and February 2020, we worked with CONICET in Puerto Madryn to aid in the 2020 sea lion census. We would join sea lion researchers as they counted sea lions manually, and we would fly the drone from above. With some of the sea lion rookeries having more than 1,000 individuals, the replicability, the efficiency, and the non-invasive collection methods of surveying with the drone really proved that this is a next step to take in sea lion surveys. So each rookery can be more than a kilometer apart on the beach, so it takes considerable effort to walk along and survey these sea lions. You can see from this image they're really spread out along the beach. So we're continuing to work on creating an algorithm that can count these sea lions. A big issue with creating orthomosaics in this image is a part of an orthomosaic is that the sea lions would move slightly, causing what we would call ghost sea lions. So orthomosaics are large stitched together mosaics of many individual images. And the purpose of these orthomosaics is to avoid confusion when counting the same individual in different images. It's easier to count individuals in an orthomosaic than it is to count them in separate images, especially when very large colonies are surveyed. So this ghost sea lion issue would happen when multiple images would have the same sea lion in them, but the sea lion moved. The software doesn't know how to process a sea lion at position X in one image and the same sea lion at position Y in another, so it produces a blurry animal. And an example of this is the sea lion on the far right, which doesn't have a head, and this is because it moved its head as the drone images were being taken. And we're still working on how to best conduct the drone surveys and how to process the images to count the sea lions and avoid this ghost sea lion problem. So now I will spend the remainder of our time to talk about the project on the Malvinas, conducting surveys for albatross and rockhoppers. The drone that was most effective for this project was the Phantom 4 Pro. So here's an image of the Islas Malvinas, which are about 500 kilometers off the coast of Argentina. And the two islands that we surveyed are in the top left, right here. They have tens of thousands of rockhoppers and hundreds of thousands of albatross. So here's a look at the two islands up close. Steeple Jason Island on the left is 8.5 square kilometers, and Grand Jason on the right is 14 square kilometers. So I'm going to zoom into Steeple-Jason, where on the southwestern side of the western half of the island, you can see there's white along the coast. And this is guano from the albatross and rockhopper colonies, showing where they nest on the island. The Malvinas government surveyed the entire black-browed albatross population on the Islas Malvinas in 2000 and 2005. However, the population was so big on Steeple and Grand that they had to extrapolate from a density estimate from smaller subsets of the population. So no direct population estimates were made on these two islands. Government researchers also conduct annual surveys on smaller, more isolated sites. So our goal was to survey the entire colony directly by drone and get a more accurate count estimate. So here are a few images of our study areas for perspective. This is the north tip of Steeple-Jason facing northwest, and the white just past the green tussock grass, those are all albatross. Here's the same study area facing southeast. The tussock makes it very difficult to survey parts of the colony without a drone. So if you kind of look at this image, each dot is an albatross, and the darker shades closer to the ocean are rockhopper colonies. Here are the two species of interest, and on the right, there are rockhoppers and albatross in a mixed colony. So I went with senior advisor for the Southern Cone in Patagonia, Guillermo Harris on the left, and my partner, Vivon Crawford, on the right. So these two remote islands were 6 hours by boat from the closest airstrip and Wi-Fi. So we really had to strategize and plan for things to go wrong. Luckily, there was a research station on Steeple-Jason, pictured here on the left, which had amenities such as electricity and a Range Rover, which made it a lot easier to get around on the island. So the first time we went to the islands in 2018, we brought with us the Phantom 4 Pro quadcopter because it flies very well in heavy winds and it can be caught manually in uneven terrain. Here you can see Guillermo catching the drone with his hands. We brought other equipment with us as well, including portable chargers. And this one, the bottom left, is a 240 watt-hour jackery, as well as solar panels. Without this equipment to charge the drone batteries, we really couldn't have been out in the field for as long as we were, and we would have had to return to the research station multiple times in a day to recharge the drone batteries. So this particular jackery could charge the Phantom 4 battery 3 to 4 times, and we brought 2 on the island so we could stay out for the whole day and we didn't need to return. So over the first few days, we were able to fly the majority of albatross and rockhopper colonies on Steeple-Jason. But at the end of our last flight on the 3rd day, the drone lost connection and we spent a whole day looking for it. We had to retire as fog rolled in, and we returned the next day. After a few hours of searching, we finally found the drone. Unfortunately, the gimbal had been snapped off, but the drone was intact. So we were able to recover all the data from the last drone flight. To take advantage of the remaining time we had on the islands, we jerry-rigged a GoPro to the Phantom 4 gimbal. And although we were flying without a live feed and couldn't see where we were going, we were able to record a large petrel colony on Grand Jason. And here on the left is an image from the GoPro, and each one of these dots is a giant petrel. So after spending a year in Argentina, working on the projects I mentioned earlier, we returned to the Malvinas and completed what we had set out to accomplish the year before, surveying the entire colonies of albatross and penguins on both of the islands. This time we brought with us the fixed wing EBX as well as the Phantom 4 Pro. And so we were wondering if the thermal camera on the EBX could detect a thermal heat signature from either the albatross or the rockhoppers. Unfortunately, the winds were too unpredictable for the fixed wing, and on the second flight, this drone crashed as well. We were not able to identify the different individual seabirds in the thermal images from the EBX. but the RGB images from the Phantom 4 Pro were sufficient to create an algorithm that could count and differentiate the two species of interest. And it is worth noting that the EB did fine in high winds in northern Patagonia, but it was the topography of the islands that caused very turbulent winds, and the Phantom 4 performed excellently. There we go. So here is an individual image from the drone. This was taken during the first time we were on the islands in 2018 when we were flying at a single elevation. And these two drone images were taken in 2019 to make it easier for the algorithm to count birds. We had to fly lower than we flew in 2018. This took more time, of course, but it was well worth it because we were able to detect the rock hoppers in the images, which we couldn't do from the imagery from 2018. So in the image on the right, seabird detections could still be made even though the birds look small and undetectable. So this is the interface for the drone software that we used on the islands called Drone Deploy. The main parameter entered is flight height, which affects flight time. In addition, an additional feature that Drone Deploy released after our time on the Jasons was the ability to contour the land. In 2018, as I just mentioned, we had problems processing the images because we flew at one flight height, but contouring the islands with the drone would have improved image resolution in the orthomosaics because the drone height above the ground would have stayed consistent. In 2019, we simply split up the flights by elevation, mimicking this software. So we returned from the mainland with gigabytes of data on our hard drives. We had been working with the Duke Marine Robotics and Remote Sensing Lab, specifically Dave Johnston and Maddie Hayes, on planning the drone flights for different projects, but we knew they had, substantial processing power at their lab. With all the images uploaded, they were able to stitch them together into orthomosaics with the software Pix4D, and in a long trial and error process, create a convolutional neural network, or CNN, that was able to count the albatross with a 97% accuracy and the rockhoppers with an 87% accuracy. And then this is the process that we use to create the CNN. The orthomosaics are split into tiles for easier computing. Then a lab analyst manually labels thousands of albatross and rockhoppers to be split and processed. So 80% are used for training the data, 10% are used for validation, and the other 10% for testing the data. The training and validation data is put into the CNN, while the testing data is used to evaluate the CNN. So this slide shows the visual review process for evaluating the accuracy of the CNN, and each grid in this image on the left is 10 meters by 10 meters. And I'm going to show you this subset of albatross in the next image. Just for some perspective. The top two images are detections that were made by the CNN, and the bottom two images show examples of false positives when the software thought that it was an albatross, but it was another seabird, or it was even a rock in D. This table shows the results for the CNN for albatross, including CNN detections compared to manual counts and the percent difference. For the sites where someone counted manually, there was a difference of 3.2%. And this table shows the results of the CNN for rockhoppers. For the sites where someone counted manually, there was only a difference of 2%. And I want to note that all of the CNN detections for both species were collected from the same aerial surveys. So the significance of this work is that this was one of the first studies to successfully use CNN to count seabirds from drone images at large mixed colonies. Here is the metadata from the 2 years we spent on the Jasons. As you can see, it really doesn't take a lot of time to fly these surveys. The drone was only in the air for a little more than 6 hours for 2019. It's really waiting for the right weather conditions, charging the drone batteries, and offloading all the data from the drone that really takes up time. So I spent the remainder of 2020 working with Natalia counting guanaco in thousands of images with the software DotDotGoose, as Antonella was showing you earlier. I also worked with the Duke lab, providing them with relevant information to create the neural network. Earlier this year, a research paper was published on the results from the surveys on the JSONs, titled Drones and Deep Learning Produce Accurate and Efficient Monitoring of Large-Scale Seabird Colonies, and it's published in Ornithological Applications. I will be returning to Argentina in January and will be bringing down a thermal quadcopter. We are hoping that this drone, the DJI Mavic 2 Enterprise Advanced, will be able to detect the thermal heat signature of a guanaco, making it much easier to filter through the thousands of images to locate the very, very difficult to spot camouflaged guanaco. I will also be working with researchers in Puerto Madryn to test the Enterprise Advanced on sea lions as well. So I want to thank everyone for listening. We had a lot of help with all of these projects, so I wanted to give recognition to the project collaborators and those that provided field and/or technical assistance for these projects. So I think it's now time to open it up to any questions that you might have for us.
You can also feel free to put questions into the chat, and we'll be monitoring that. But please unmute if you have any questions and go ahead and ask Quade, Natalia, and Antonella.
Hey, Wade, have y'all picked out any propellers to test for noise levels, disturbance?
No, there are not. I think that recently the Phantom 4 released their next level of quieter propellers, but we haven't considered it, no.
Hi guys, really nice talk. I enjoyed it a lot. I have a question, and based on the picture you have presented, it looks like the guanacos are very, very sensitive to the drone. They just disperse, or they get nervous and moving around. It's like if you start flying over a crowd of guanaco, they just fly away, or they stay moving around and you can make a count.
No, they definitely run away quite fast, I would say. That's why we think that one of the main triggers of the guanaco reaction is the noise, because we flew quite high, at 180 meters above the ground level. So that would make quite difficult for the guanaco to actually see the drone, but to hear it, and especially on the places that we work, they are very open grasslands with basically no other ambient noise. So we believe that the noise is the main trigger, and basically they hear it and detect it as long as we lift it up. We can see the animals like turning the head in the direction of the drone, but is when we approach the drone that they react, moving away. And in that situation, it's almost impossible to count them. So now it's a huge problem for us to find the correct height to fly the drone, to be able to identify them then in the pictures, but at the same time not causing a very huge behavioral reaction. So yes, and it's always also important to say that we did not see this dramatic behavioral reaction in all the populations that we flew. For example, when we tried flying in Aucamahuida, we could flew a little bit lower because the guanacos were more adapted to the human disturbance. There is there is oil extraction very near. There is a lot of trucks. There's a lot of human movement in Aucamahuida, unlike La Pajunia. So we believe that maybe guanacos are more used to the disturbance than in La Pajunia population. And also in the captive population, where animals are very used to humans, they react even less. So we hypothesis now with Natalia and colleagues is that the reaction of the drones depends on the disturbance history of the guanaco population under study. With very, very undisturbed populations reacting a lot, and maybe populations that have a lot of disturbance, but it's not a negative disturbance, reacting less. We have to prove that now.
Yeah, I want to make a quick comment on that. Just comparing the flight heights. I remember in Pajunia, if you're getting to, 180 meters, you were kind of pushing it. They were getting skittish. In Aucamahuida, you could fly 30 meters, 40 meters above the guanaco, and they still wouldn't scare. So.
Yes, the species is very plastic in the behavior. There is another studies with that evaluated different human disturbance and found similar results regarding the history of disturbance of the population. So we think that this is a factor that important to mention and to take into account.
Thank you. I have another one. Wait, that is for you. That you mentioned that you make an artificial intelligence system for detecting the albatross. Then you make a table showing the data of manual counting and the software counting. Do you have, or have you measured how long did it take to do the manual counting, and how long did it take to make the artificial or the machine learning counting?
Yeah, so I was indirectly involved in making the convolutional neural network, the CNN, but I would say manual counts took maybe 15 hours to count maybe 1,000 albatross, just drawing a rectangle around them to identify them and teach the software to learn what an albatross is. And then I think that the software maybe took about a day to process, and there was a lot of pre-processing that took place before the software actually went through and recognized the albatross. But yeah, about those times, and I think that they say a more specific number in the drone paper that was published in Ornithological Applications.
Do we have any more questions in the chat? No.
I have one question, if I may.
Please.
So yeah, thank you both so much for really interesting talks. I was just wondering, given that you've mentioned this kind of variability between populations in responses to drones, do you think it's possible to kind of drop recommendations for like trying to avoid disturbing wildlife, or whether it's just that kind of disturbance testing needs to be put into the plan for any study that's going to use drones in this way?
So is your question that if we can, with what we have right now, recommend some guidelines for people that want to fly sensitive wildlife? Is that your question?
Yeah, or is it just that any study should involve this kind of testing as a first step?
Well, I think it's really important to do at least some pilot flights to kind of get an idea on how sensitive and how reactive is the population under study, and definitely considering the sociability and maybe the anti-predatory strategies in the case of herbivores, it's quite useful. It was useful for us to make hypotheses and make predictions to anticipate what we were going to find before conducting the experiment. So taking all that into account before flying and doing some testing flights to see if you are right, maybe with groups at of different sizes, it would definitely be a good idea. Of course, doing an experiment like this before actually starting if your goal is a population survey, maybe it takes a lot of time. If you ask me, it was great that we did it, but I do acknowledge that it takes a lot of time. But definitely trying to fly first before jumping into the population surveys is a good idea.
Thank you very much. That's really helpful.
Thank you.
Can I add on to that comment? Hi, everyone. So in regards of our experience with crocodiles here in Belize, we have been conducting drone surveys in some areas that are next to communities. There's a lot of boat traffic, and then we have conducted surveys in areas that are more isolated. The crocodiles are rarely going to encounter humans. What we have noticed is with the crocodiles in areas near urban locations or communities where they're used to boats in regards of the sound that a boat motor makes, we were able to drop the drone not very high. We were able to get it pretty low where we were able to get good shots of the transverse row patterns. And it just seems those particular crocodiles are very used to noise. So it didn't seem to bother them that we were hovering our Phantom 4 quite low above them. However, those in the isolated populations, it took about 4 to 5 months for them to allow us to get the drone fairly close to them. I remember the first time in one of the populations, when we first started the survey in the isolated area, we had the drone 50 meters and those crocs were very wary and disappearing. And it took about 5 months, multiple times a month. I mean, these were locations close to our main facility location. So it was easy enough to go back and forth. But it did take about 5 months where eventually we were able to get the drone about 15 meters and get some really good shots of these crocodiles that were once just very, very wary of the drone. So that's been our experience here in Belize around the Placencia Lagoon.
Thanks for that input, Marissa. That's very interesting. I have sort of an observation for Wade with the sort of neural network, deep learning things you've been doing. I was especially intrigued by the photo mosaics of the colonies and the spacing of the animals. Have you gotten to the point in processing where your resolution is good enough to measure size of individuals, or just spatial volume, and look at the space use in the colony, like distribution of animals? Are they denser in the middle and thin out towards the edges? Are you able to look at that sort of thing yet?
We haven't really spent the time looking at those specifics. This initial survey was really to get a number on how many albatross and rockhoppers there are, just because there were so many there. I think that the CNN calculation said that there were 204,000 albatross on the islands. And I think there was 55,000 rockhopper penguins as well. So the initial survey was just to get a more accurate number.
Great, thanks. Do we have any additional questions? comments?
I have a question for Wei.
Yes.
Yes. Hi, Wei. I want to know, in your experience with thermal cameras, do you think that could work with guanacos into the forest, for example? What do
In
you
a
think?
forest, I guess, what do you mean by forest? And how's it going, Natalia? It's great to see you.
I mean that if you think that we can detect guanacos into the forest with a thermal sensor?
I think so, as long as the forest isn't too dense and you're still able to, see the guanaco can be seen from above through the forest. I think as long as, you can see the guanaco, the drone should pick up the thermal heat sensor from the guanaco. I've heard of studies of monkeys that are, not just in the top canopy, but kind of deeper in the forest that have been detected. So I definitely do think that it is possible. And to add, I think that with the quadcopter drone that I'll be bringing down, it's a lot easier to, focus on the area of interest compared to the fixed wing, which, it's flying along. You can't really, stop it and get a still image. So I do think that it will be possible.
Okay, thank you, Wei. I hope to see you soon.
Yeah, see you soon for sure.
Okay. Carlos, Lonnie, do you have anything to add before I make the announcement of the next workshop?
Well,
I don't have anything.
I just want to say that about the Natalia. A few talks ago, we have a presenter from Brazil that is working, have been flying with thermal cameras, and he saw in a very dense canopy monkeys and birds under the canopy. So I guess on your area, which is not that much dense, you don't have a very dense forest. At least the place that you have been showing, there is no forest at all, actually. But in some other part of Patagonia, you get some forest area that I guess you will be able to see the thermal signature. We've been counting deers in timber properties, where they produce forest, eucalyptus and other trees, and even using a regular camera, if you look at it, you will see the thermal camera, you will get a mark, a red mark or something. I guess they will be very useful for counting the guanacos.
And how about to detect the species? But I imagine that you can detect a mammal, for example, but
yes,
yes,
yeah, sure. But you have the two sensors, the drone that Wei pretend to use. It does a thermal camera plus a regular camera. It has both of them and shooting at the same time. So you will have the thermal record plus the regular scene picture. So you will be able to identify it.
It also has this drone he's taking down. This thermal camera also has a zoom, and the regular camera has a zoom. I believe the thermal camera has a was it 18 times zoom, and the regular camera's got a 32 times zoom. So you can actually fly higher.
Yeah, 16 for the thermal and 32 for RGB.
Other questions or comments? And I want to thank all our presenters for really excellent presentation, very informative.